Today we're going to look at more solving by factoring. So same concept that we looked at yesterday, just slightly more complex problems or maybe some different things that we'll have to consider. So the first problem that I want to talk about, if you choose to solve by factoring, so I'm going to sort of do that line down the middle. If you choose to solve this by factoring, the dilemma with solving this by factoring is that this is not a special case as it stands. So if we were going to solve this by factoring, we have to remember that rule where the first thing we always look for is a GCF. So this does have a GCF of 3, so we would factor out the 3, and then that factors into a 3 times an x squared minus 9. But then, right, we can continue factoring. It's that factoring completely concept we looked at the end of our last unit. So x squared minus 9 now is a special case. So this would turn into 3 times an x minus 3 times an x plus 3, right? And we're replacing that with our equal 0. So we would set all of the things that are being multiplied together equal to 0. So technically speaking, we're going to set 3 equal to 0, but we know that 3 will never equal 0, so that's just a silly one. We'll say x minus 3 equals 0 and x plus 3 equals 0, and we will solve each of those. This one will give us x equals negative 3. Okay, so if you choose to go the route by factoring, you need to know how to solve it completely. Now, for those of you who aren't comfortable with that, right, this 27 doesn't have an x on it, so you can still solve this by taking a square root and just use inverse operations, right? You can add this 27 over and divide by 3. And when we square root, the square root of 9 is plus or minus 3. So we'll have two answers of 3 and negative 3. Now, number 2 is sort of the reverse order, right? This is one that you can straightforward factor into a special case. So this would factor into a 2x minus 5 and a 2x plus 5, right? And we can set each of those equals to 0. Right, but when we solve these, we don't get integer values. Right, so we get a 5 over 2 and a negative 5 over 2. Right, so if you choose to solve this by factoring, there's nothing really weird on that one. But if you choose to solve this by taking a square root and you choose to add that 25 over first, which will give us 4x squared equals 25, then when you divide by the 4, right, this is still a fraction, but that's actually okay. You can either use a calculator, or when you go to square root both sides, what we're really doing is we're taking the square root of 25, which is 5, and the square root of 4, which is 2, and putting a plus or minus in front of it because we added the square root. Now, the other part that is more complex with factoring is what happens when you can't just take a square root or special case. We still want to consider that factoring completely concept. Now, again, like I said yesterday, for some of you, you might need to rely on the third option that we're going to look at later in the week. But for those of you who are pretty quick at factoring, right, this number 3 is already set equal to 0, so that's good. So our next step would be to ask ourselves, is there a GCF? And this does have a GCF of 2. And by factoring out that GCF of 2, right, we get to a much smaller trinomial in here, right? Instead of taking 2 times 80 and listing factors of 160 and then having to factor the long way, right? In that factoring completely process, now we're just factoring on what's based inside the parentheses. So we're going to say 1 times 40 is 40, right? We're going to list our multiples of 40. Right, and we want the set that will add to negative 13, so we want negative 5 and negative 8. And x here is 1, so we are able to use our shortcut, and that becomes an x minus 5 and an x minus 8, right? This 2 is still part of the factored portion, but when we go to set these equal to 0, right, 2 equaling 0 is never going to happen, so that doesn't really matter. So we'll say x minus 5 equals 0 and x minus 8 equals 0, and solve those. And so we'll get x equals 5 and x equals 8. Okay, when we look at number 4 does not equal 0. So the first thing that we need to do is make this equal 0. So we'll move that 50 over, right? These are not like terms. And again, if we can factor out that GCF, it will make that factoring a lot simpler. So this has a GCF of 5, so I can plot a 5. And then we're going to focus right here on the trinomial. So we'll say 1 times negative 10 is negative 10. Right, and we want our larger one to be negative. So we want 2 and negative 5. So we'll have an x plus 2 and x minus 5. Now this 5 again is really still part of it. But setting 5 equal to 0 is never going to happen. So that's just not worth solving. So we'll say x plus 2 equals 0 and x minus 5 equals 0. And we'll get answers of negative 2 and positive 5. Now the last two options we're going to look at, you really kind of have to be committed to solving by factoring or really be good at solving by factoring for this to be the most effective method. Right? This does equal 0, but when we try and look for a GCF, there isn't one, which means we're going to have to factor the long way. So we take 3 times 8, which is 24. Right? We're going to list our factors of 24. We want the pair that adds up to 10. And we want both of them to be negative. So that 2 and 12 can be tempting, but we need a double negative. So we need negative 4 and negative 6. So this will then split into 4 terms. So a 3x squared minus a 4x minus a 6x plus 8. And we'll have to factor this by grouping. So we're going to split it in half. Our GCF on the left side is x. Our GCF on the right side is going to be 2, but because that leading one is negative, it'll be negative 2. So this will factor into an x minus 2 and a 3x minus 4, right, equals 0. So now we need to set both of those equal to 0. So all of that work was just to get it factored. Our next step is then to set each of those factors equal to 0. So I'll say x minus 2 equals 0 and 3x minus 4 equals 0 and solve both of those. So we'll get x equals 2 and x equals 4 over 3. Number 6 also does not equal 0. So if we're going to solve this by factoring, we need this to equal 0. Now, it might be tempting to subtract this 5x squared over because then there's only one piece to move. But factoring is way easier when a is positive. So keeping your a value, your number in front of the x squared positive, is going to make the factoring a lot easier. So I would suggest moving both the 2x and the 7. So we're going to move a positive 2x by subtracting it and a positive 7 by subtracting it, right? We're doing the same thing on both sides. They're not like terms, so I just move them both at once. But you could move them in 2 separate steps if you wanted to, but right, nothing here is like terms, so they're just shifting to the other side. Then once we're set equal to 0, right, there's no GCFs, so I'm going to take 5 times negative 7, which is negative 35, and list my factors. I want my larger one to be negative, so I want 5 and negative 7. So I'm going to split this up into 4 terms. So I'll get a 5x squared plus 5x minus 7x minus 7. I'll split this in half and factor by grouping. All right, 5x divided by 5x is 1. Our GCF over here is a negative 7 because the leading one is negative. 2 negatives make a positive, so we'll get a 5x minus 7 and an x plus 1. But again, that's just to replace it in the equation to make it equal 0. We still have the final step of setting both of those equal to 0. So now I need 5x minus 7 equals 0 and x plus 1 equals 0. we'll get x equals 7 over 5, and x equals -1.